Hello everyone, my name is Michael Spielt from michaelscodingspot.com, and today we're going to talk about debugging exceptions in Visual Studio. So let's see an example. I have a small program here and I'll write some code that should throw an exception. For example, as you know, we can divide by 0. So this code should throw an exception. Let's start the program, or place a breakpoint here and start it. So I'll just hit place a breakpoint here and hit continue. Now, as you can see, Visual Studio tells us there was an exception. The exception type is system.divide by 0 exception. The exception message is attempted to divide by 0, and it's an unhandled exceptions. There are two types of exceptions. There are handled exceptions, which are caught in a catch clause, and there are unhandled exceptions, which are not caught. And Visual Studio has some rules as to when it breaks an exception and when it doesn't break an exception. And when it's an unhandled exception, Visual Studio will always break on the exception during debugging, and you will see the kind of window that you see here. When it's a handled exception, also known as first chance exception, so unhandled exceptions are called second chance exceptions, and handled exceptions are called first chance exceptions. Whether Visual Studio will break on first chance exceptions depends on several on configuration. This configuration is available from Debug Windows exception settings. And what we care about in a .NET program is common language runtime exceptions, CLR exceptions. When this window is checked, Visual Studio will break on all handled exceptions. When it's unchecked, Visual Studio will never break on first chance exceptions. It will just break on second chance exceptions. Let's see an example. So I'll just remove this code here, and I do have a small handled exception here. I'll just check this, stop on all CLR exceptions, and start the program. Alright, so an exception was thrown. It's an index out of range exception, and the message was index was outside the bounds of the array. Visual Studio writes exception thrown. This is the message for handled exceptions. If we explore further, we'll see that the item index is -1, and items here is an array, and when we try to access -1 in an array, it's out of range, it's an illegal index, so Visual Studio threw an exception. Now let's try this again, but this time I'm going to uncheck break on CLR exceptions, and I'll stop debugging with debug stop debugging, and I'll place a breakpoint here and start. Now the exception is thrown here. Let's debug this with F11, and I'm just clicking F10 here, step over, and this is where the exception is supposed to be thrown, F10. And now the exception was caught, but Visual Studio did not break on the exception. We can investigate the exception itself. Index was outside the bounds of the array. Let's talk about rules on what happens when an unhandled exception was thrown. When an unhandled exception was thrown, that means it was never caught in a catch clause. The process is going to terminate. Now Visual Studio is always going to break on the exceptions. We said on unhandled exception, we said that before, and the process is always going to terminate after the exception happened. Let's see an example. I'm going to show you the same example as we saw before with divide by 0. And we'll see that Visual Studio never reaches this breakpoint. But this is in the main thread. If I were to use a thread pull thread, the process will still terminate. Now we're starting a thread pull thread, which will throw an unhandled exception. Visual Studio breaks on unhandled exception as expected, and the process will terminate. So there are a couple of exceptions, not exceptions, but there are no exceptions to this rule, but there are a couple of scenarios where you might think this is not true. For example, if I were to use the task API, task.run, this will actually not terminate the process. I'll show you. And as you can see, Visual Studio is still debugging and the process wasn't terminated. I'll run it again. In this case, even though the exception wasn't handled, on the thread that we created in task.run, the process wasn't terminated because it was handled in non-user code. Visual Studio even tells us this in the title, exception user unhandled. So it was handled by the .NET framework itself, but it wasn't user unhandled. If we go to the call stack, which is available in Debug Windows, call stack, I'll just move it here, we can see that there's external code here, which we can see by checking this part. So we see that our method, our delegate, was actually called from a bunch of other methods created by the system threadings task classes, and somewhere in this code the exception is handled, and that's why we don't the process doesn't terminate. Another scenario is when you're using ASP.NET and you have an exception in your code in an HTTP request, and the process doesn't terminate there as well. That's also because ASP.NET itself handles the exception, and that's why the process doesn't terminate. By the way, this behavior was changed in .NET 2.0. Before that, in .NET 1.0 and 1.1, exceptions in thread pull threads were handled and the process didn't terminate. You can go back to that behavior by doing some configuration, which I do include in the blog post, but it's not recommended. Let's talk a bit about the exception pop-up and the exception settings. I'll run the program again, but this time I'm going to check the CLR exception. I'm going to delete this code and run it again. Visual Studio stop on handled exception, and let's talk about all the settings, all the options in this pop-up. View details will open a quick watch window with where we can investigate the exception. We can see all its properties. By the way, an exception is a regular class in .NET, which derives from the exception base class. It has properties and the especially useful property stack trace, which will show you all the methods that were called and up to the exception was thrown. Copy details will copy the exception type, the exception message, and the exception call stack to clipboard. This checkbox here you can, by unchecking it, you can tell Visual Studio not to break on this type of exception in the future for first chance exceptions. Second chance exceptions, Visual Studio will always break anyway. So our exception in this case is index out of range exception. Let's look at in the CLR exceptions here. System.index out of range. Here we go. Now by unchecking it, it will be unchecked here. If I were to run the program again, Visual Studio would not break on this exception because it's a handled exceptions, and we just told Visual Studio don't break on index out of range first chance exceptions. I can return it. Now I can also tell Visual Studio to not break on exceptions on this type of exception in this assembly, in this executable. So by checking, you can see that the condition was added here, and we can actually access the conditions in this button, Edit Conditions. Now we can say S4 system.indexOutOfRange exception. We can add conditions according to module name. So the open exception settings opens the exception settings, and edit conditions opens that window that we saw before, same as this button here, edit conditions. Now in the exception settings we also have a few options. We have show only enabled options, which when just this is enabled and I click on the filter, it will show just this type of exception. The plus here, we can actually add our own exceptions for Visual Studio to break on or not to break on. For example, I have an exception here, my exception. If I wanted to add it, I would need to do like this. I would need to add the full name, the full qualifier name, which is the namespace dot class name, my exception. Now I can determine whether Visual Studio should break on it or not. And of course we can restore the list to the default state. Let's talk about some of the more advanced Visual Studio features. One of those features is if we go to debug options, enable just my code. So this is actually a very important feature. When checked, which is the default value, it tells Visual Studio, as far as exceptions are concerned, break only when an exception is thrown in user code, in my code. If an exception was thrown in the .NET framework or third-party library, Visual Studio will not break on those exceptions. We usually want to keep this on, because if we turn it off and you'll run something like an ASP.NET application, you'll see a whole bunch of exceptions being thrown every second or so, and your debugging experience is going to be very poor. Now let's do a little experiment. I have a small example here, enable just my code example. I'll hit F11 to step into the method. Now let's say I'm using the Newtons of JSON convert here, JSON.NET library, and I'm trying to deserialize an object of type warehouse, and the string that the JSON that I'm giving it is an illegal JSON. So I expect an exception. I'll mark here for Visual Studio to break on all exceptions and hit F10. One more time. So as expected, an exception was thrown. If we go to the call stack, here we're going to see a bunch of methods in the JSON.NET library, with the last method being deserialize. Of course, we can't see the code. Let's do this again, but this time I'm going to turn off the enable just my code setting and start again. F10. So now we have a little more information. For one thing, the call stack, we have a few more methods. Before, deserialize was the topmost method. Now we have read for type, read, and parse value as well. This might not seem like much, but actually it can give you a whole bunch of hints as to why the problem occurs. Also, if you're going to debug the third-party library with a tool like dnSpy, then the full call stack can give you a much better indication on where to place the breakpoint to debug. As I told earlier, this checkbox is most useful in exceptions that you don't even see. For example, sometimes you have an ASP.NET application and some request returns 500, and in your code nothing happens, even though your exception settings say break on all exceptions. Still nothing happens. What could have so this could indicate that an exception did occur either in the ASP.NET framework itself or in some third-party library that maybe added a middleware that throws an exception and fails the request, but you don't actually see that. So for that you will need to go to debug options and uncheck enable just my code and send the request again, and now you will be able to see the exception. Let's return it to the default value. The next advanced feature that I want to talk about is Unwind to frame. This is a very powerful, lesser known feature, and I'm going to show you an example. So in this case, I have a divide by random method. Let's see if it works. Yeah, so we got a divide by 0 exception. I'm going to run again because I want this to turn into an unhandled exception. Alright, exception unhandled. If I go in the call stack one step up, I can see that rand returned 0. That's why we have a divide by 0 exception. And suppose I want to fix it without actually running the program again. What I can do is I can right click and use the unwind to this frame, or in here in an even topper method in the call stack, I can unwind to this frame. So when right now the debugger location is somewhere in the special location, there's not a next statement to execute. The last statement to execute was this one, and it threw an exception. I can unwind to frame here. This will actually go back in time to when the exception still didn't happen, and the next statement to execute is going to be this expression. Now we can use edit and continue. Say I hit F11, and I actually can edit the code and change it so the exception doesn't happen. I have a class here called myRandom, and random.next actually always returns 0. I can change it to use instead new system.random, and here I'll add +1 so it never returns 0. And now I'll do F10, 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 and obviously the exception doesn't happen because RNG is some big number. The final feature I want to show you is IntelliTrace. For that I'm going to switch to Visual Studio 2017 because I have an enterprise license for 2017, and IntelliTrace is only available for Enterprise Visual Studio. Now IntelliTrace is a very nice feature. It allows you to record the execution as it happens and sort of go back in time to some events that happened during execution. So events might be debugger events like stop on breakpoint or step over, or it might be exceptions. And a whole big list of other stuff which we don't care about right now. So I'm going to turn off the CLR exceptions, and we know that this method does throw an exception, a handled exception, and I'm going to turn on the IntelliTrace. To do that we have to go to Debug, IntelliTrace, open IntelliTrace settings. There are two main modes which we care about in IntelliTrace. By the way, if you don't have an enterprise edition of Visual Studio, you will not see this part of the options. Now we can IntelliTrace events only, or we can IntelliTrace events and call information, which I'll click on now. Oh, okay. Options do not have effect. Okay, never mind. I'll stay with IntelliTrace events only, and I'll talk about the difference in a minute. Now let's start the program. And what IntelliTrace does, it populates the events tab here. So we can see that an exception was thrown and an exception was caught. And I actually can click on this exception. This brings us to a special debugging view, which is called historical debugging. That's why you can see that the statement here is in a special orange type of color, and I can actually see what happened during the exception. Now in this case, if I hover over item index, we'll see that data not available. See the locals window for available IntelliTrace data. If we were to be in the other IntelliTrace option, which is debugging IntelliTrace, if we were in this mode, then we could have seen local values, which includes the item index. But that other option can impact performance. Well, actually both options can impact performance, but the call information has much bigger impact. And also we can navigate to the catch clause where we caught exception. And so IntelliTrace is a pretty powerful feature if you're lucky enough to have Visual Studio Enterprise. That's it for today. Thanks for watching. Now you can go to the full blog post where I go into everything in this video, maybe in some parts in some more detail. Thank you.